Hi students, welcome to the session on basic discrete time signals. Okay, let us start. So these signals are very important and widely used in the analysis of system design. So we must understand it very clearly. First one is unit step signal, right? So unit step signal is represented by U of n. This symbol, this notation is specifically allocated for unit step signal. So it is defined as U of n is equal to 1 when n is greater than or equal to 0. 0 when n is less than 0. Right? So this is what unit step signal. Right? How can we draw the signal? You see, let us have x-axis n. Discrete time signal x-axis is represented with n. Y-axis u of n, the magnitude. Right? So how can we draw when n is greater than or equal to 0? It is 1. So let us start from n is equal to 0. It has only discrete instance. So n will take only discrete value, that is 0, 1, 2, 3, 4, 5, like that. So when n 0, u of n is 1 only. You substitute u of 0 is 1. So 1. When you substitute n is equal to 1, u of 1, that is also 1. So 1. When you substitute n2, u of 2, again that is 1. u of 2, 1. When you substitute n3, again it is 1. So whatever be the n value, it will go up to infinity 1 only. So this is what u of n, unit step signal. So what is the value of u of 0? u of 0 is nothing but the value of signal u of n at n is equal to 0. This is u of n. When n is equal to 0, the value is 1 only. Similarly, value of u of 3. u of 3 is nothing but value of this signal when n is equal to 3. When n is equal to 3 also it is 1. So like that we have to know. These are all called samples, individual samples. So this every symbol is every value is represented by sample. So how many samples I have drawn here? I have drawn 4 samples, right? So I don't take continuous value. I have taken sample of the continuous. That's what it is known as discrete signal. So I have taken only 4 samples. 0, 1, 2, 3. 4 samples I have taken. Okay, this is what unit step signal. Next, what we have to know is unit ramp signal. Unit ramp signal, right? So unit ramp signal is given the notation R of n. So R of n is defined as that is equal to n for n is greater than or equal to 0, 0 and n is less than 0. Right? This is what R of n. Let us see how to draw this. Right? So x-axis n, y-axis R of n. Right? First we substitute n0. When n0, R of 0 is equal to n is 0. R of 0 is equal to 0. So when n0, R of 0 is 0 only. Fine. Okay. When n is 1, when you substitute n is equal to 1, this is also 1. So for 1, the value is 1. Right? When n is equal to 2, R of 2 is equal to 2. Because R, in wherever you find n2, substitute 2. R of 2 is equal to 2. So 2 is 2. Right? This is 2. When n is equal to 3, R of 3 is equal to n is 3. So when it's 3, it is going to be 3. Right? So like that it will go. This is what unit ramp signal. Right? So what is R of 3 value? 3. Similarly, R of 4, when n is equal to 4, R of 4 is 4. R of 100, R of 100 is nothing but 100. Right? This is what unit ramp signal. Okay. Then another signal we have to remember is already I posted one video on impulse. So anyway, you remember del of n, that is unit impulse signal. This is very important. I have put separate video, just I recall here. Unit impulse signal, which is given by this del of n is specifically allocated for unit impulse, that is given by del of n is equal to 1 when n is 0. 0 for otherwise n not equal to 0. So how can we draw? This is telling that n, see x of n is x-axis, del of n is in y-axis. this del of n has value only at n is equal to 0. When n is equal to 0, del of n has a value of 1. So this is n is equal to 1. It has a value of 1. This is what unit impulse. Only one sample is there. That's why it is called unit impulse. You can call this is an impulse or sample. Right? So only one sample is there. For all other n is equal to 1 to up to infinity, minus 1 to minus infinity, the value is 0. So no need to draw. So this is what unit impulse or unit sample signal. Other name is unit sample signal. Right? So that's all about this session. I hope you understand everything clearly. If you have any doubt, please ask me in comment section. Thank you.